Okay, now we're going to start talking about how we divide square roots. Now, division is always kind of tricky. It depends on whether the numbers are divisible or not. So let's look at the square root of a divided by the square root of b. Now, we can use property of exponents to show that that's the same thing as writing it as one square root of dividing a by b. So you can take two separate square roots that you're dividing and write it as the square root of a quotient. Now, this is a good thing to do when the number a is divisible by the number b, because if you can just divide that out, then you just do it and it'll be simpler. So, for example, if you have the square root of 10 divided by the square root of 5, 10 is divisible by 5. So if you use this property, you can write it as one square root instead of two separate ones you're dividing, and divide the radicand. So you divide 10 by 5. And then, like we said, 10 divided by 5, that will work out evenly. So we will have the square root of 2. All right. Now, this could be done in your head. Square root of 10 divided by the square root of 5 is going to be the square root of 2. All right. It's just the reverse of the square root of 2 times the square root of 5 is equal to the square root of 10. So it's logical to just do that in your head. All right, now here's another one. We've got the square root of 350 divided by the square root of 7. So 350 is divisible by 7. So you could just do, 350 divided by 7 is going to be 50, and you could just come up with the square root of 50. Okay. Or it doesn't hurt to write out the step when you're doing division, because these are kind of hard. Now, that would not be the final answer, because 50 has a square in it. So you need to do the prime factorization of 50, where you do the factor tree. And so it's going to be 2 times 5 squared. And there's the square, and that'll simplify. So we're going to end up with the number 5 times the square root of 2. That will be the final answer. Okay, now if they throw in some extra things to the problem, so let's say we have not just the square root of 27 divided by the square root of 3, but we also have an 11 in there. Okay, so any extra numbers, you have to pay attention. Are they in the numerator or are they in the denominator? So if it's in the numerator, this is basically the same thing as 11 over 1 times the square root of 27 divided by the square root of 3. So 11 over 1 is really just 11. You're multiplying with that 11. Okay, so what we have is 11. Now 27 is divisible by 3, so we could just say 27 divided by 3 is 9. So we'll have the square root of 9. And then the square root of 9, that is just 3, since 9 is 3 squared. Okay, so you can do that in your head. Right? Or you could write 11 times the square root of 3 squared, however you want. But you're going to have 11 times 3, and then you're going to wind up with 33 for the final answer. Okay. All right. Here's one where there's an extra number in it, and it's in the denominator. So this 5 is not really the number 5. This is really like 1/5 times the square root of 6 divided by the square root of 3. So you have to keep track. That 5 is something you're dividing by. It's going to be in the denominator if it doesn't simplify out. Okay, so we can divide our square roots since the square root of 6 is divisible by the square root of 3, and we'll get the square root of 2. So we have 1/5 times the square root of 2. Now that's the same thing as the square root of 2 over 1. So when you put it all back together, and in most cases you will, you're going to write that as the square root of 2 divided by 5. Okay. There are occasions where somebody might write this as 1/5 times the square root of 2. Okay, for now, we're going to write them all as one fraction.